Okay, class, in this lesson, you're going to learn how to solve real-world problems involving markups and discounts. Before we start, let's define what a markup and a discount is. An example of a markup is when a store sells items for more than it pays for those items. That amount of increase is called a markup. So for example, let's say you own a store and you want to sell candy. Let's say a Hershey's chocolate bar. And for you as a store, it costs you $1 to purchase each Hershey candy bar. So when you sell it for $1.20, that is called a markup. That 20-cent increase is the markup. So then the amount that the customer pays for that item, that $1.20, is the selling price. So let's take a look at an example. Okay, so in this problem, you are to find the selling price if a store pays $42 for a pair of inline skates, and the markup is 25%. So the first thing to do is to really understand what the problem is asking you. So the problem tells you that the store pays $42 for the skates. Okay, so that is their cost, $42. And the markup is 25%, so they're going to sell it for more than $42 by a markup of 25% or an increase of 25%. So there are two ways to solve this problem. Okay, the first way is to find the 25% of $42, and to do that we're going to multiply that by 0.25. And when we multiply that through, we get $10.50. So the $10.50 represents the increase in price that we need to apply to the $42. So then the final price then becomes 42 plus 10.50, which is equal to $52.50. So $52.50 is our selling price. Okay, so this is method one. So in this method one, the approach that we took was finding the amount of the markup first. Okay. The second method is to find the total percent first. So since we're marking it up by 25%, we need to take 100% of the costs plus 25% of the markup, and we get 125%. Now that we have the total percentage, we can take the cost of $42 and we're going to multiply it by 1.25. So that's 125% converted into decimal. When we multiply 42 by 1.25, we get the same answer of $52.50. Okay, so this would be method 2. Okay, so let's take a look at another example. Okay, Big 5 is having a sale. A volleyball has an original price of $59. It is currently on sale for 65% off the original price. We are to find the sale price of the volleyball. Okay, so in the previous problem, we talked about a markup or an increase in the price of a product. Now we're talking about a discount. Okay, when something is on sale, the price is going to drop from the original price. So we know from this problem that the price of the volleyball, the original price, is $59. We also know from the problem that the sale is 65% off. So to find the discount, we're going to multiply 59 by 0.65 and we get $38.35. Okay, so this $38.35 represents how much the price has been reduced. Okay, so then the second step then is to take $59 and subtract $38.35. And then the final price will be $20.65. And this is the sale price. And this I will call method 1. The second way to do this is involving percentage. Okay, so this requires a little bit of thinking, logical thinking, but if you do it this way, the calculation is actually much easier. And here's what I mean. So if the sale price is 65% off, then what that means is that the customer is going to pay 100% minus 65% or 35% of the original price. Okay, think about this. The sale or the decrease in price is going to be 65%. So what's left over, which is what the customer has to pay, will be 35%. This is why you subtract 65% from 100 and you get 35%. Once you have that number, then you can take $59 and multiply that by 0.35, and that gives us the same amount of $20.65. That is also the sale price. And I'm going to call this method 2. Okay, so far we've gone through 2 examples. The first one was a markup, or an increase in price from the cost to a store. And then in this problem, we dealt with a discount or a sale price. That is a decrease in the price of the product. Now we're going to go on to a third example. Okay, so let's take a look at this example. Henry had a 25% discount on hockey equipment. The selling price was $172.50. What was the original price? Okay, so this is a little bit different because we're given a 25% discount, but the difference here is we're now given the selling price. Okay, so that's the price after the discount or the decrease in price. So he ended up paying $172.50. The question is, what was the original price? Okay, so this problem we need to think a little bit more carefully. Okay, there are a few ways to solve this, but I'm going to demonstrate what I believe is the simplest way to get to the solution. So we're going to do this algebraically. So let's say OP represents the original price. Okay, now we know that there's a 25% discount. Okay, so what the selling price becomes, okay, to get to the selling price, we actually have to take 75% of the original price, right? Think about that. We have the original price, which is what we're trying to solve for, okay? We know what the selling price was. This is what we ended up paying, okay? We also know that the discount was 25%, so we have to take 75%. That's 100 minus 25, or 75% of the original price, okay? If we took 25% of the original price, then that's the discount amount, okay? That was the actual reduction. But but that's not what we want. We want to know what the selling price is, or what reduction took place to get to our selling price. So we have to multiply it by 75%, okay? So I'm going to just add a little note here. This is 100% minus 25%. Okay, so the key to this problem is setting it up correctly. Once you do, then all we need to do is solve for OP, or original price. Okay, and if we solve for OP, we're going to get $172.50 divided by 75%. That is equal to $172.50 divided by 0.75. And that amount comes out to $230. Okay? So $230 is the original price. So think about it. Well, actually, whenever you get an answer to a word problem, don't just finish there and move on to the next. You need to pause, look at the answer, and ask yourself the question, does this make sense? Okay? So if the original price was $230 and you take a discount or a reduction of 25%, does it get us to $172.50? The answer is yes. Okay. If you round the amount down to $200 and you take 25% off, okay, 25% of $200 is $50. So you subtract $50 from 200, that's $150. Okay? Since this is $230, the final price is going to be a little bit higher than $150, and therefore $172.50 makes sense. Okay? So let me just review that, because that may have been a little bit confusing. So the final price of the hockey equipment is $172.50, and that was after a 25% discount. Okay, so we want to know what the original price was. So obviously the original price is going to be $172 or higher than $172.50. Okay, so the way I've done this is set this up with an algebraic equation. Okay, very simple algebraic equation. So I said, okay, I don't know what the original price is, but I'm going to call it OP, original price. Okay. Now, I have to take 75% of that, okay, to get to my selling price. And the reason it's 75% is because I'm receiving a 25% discount. That is the decrease. So the final result will be 75% of the original price. And that is why we set the equation up to be OP times 75%, which is equal to $172.50.